This is so hard. What's wrong, Riri? I can't understand this lesson, and I'm also confused about this. Oh, Macy? Ooh, it's atomic models and valence electrons. Can you help me to understand this, teacher Rhianne? Sure, Riri. This is Rhianne Escat, your chemistry teacher for today. Are you ready to learn something about these two? Come on, let's dive into our new adventure of chemistry today. Zoom in. Let's start with atomic model. I have a question for you. What is an atomic model? An atom is made of nucleus holding protons and neutrons inside, and all of these have electrons orbiting them in shells. The count of particles present in an atom can be calculated using its atomic number and mass number. There are some researchers who believe Leucippus of Miletus originated the atomic philosophy of the early Greeks. Democritus of Abdera, a famous disciple, named the building blocks of matter atomos, meaning indivisible. He proposed that atoms of the four elements, earth, air, fire, and water, are spheres of different sizes, forming one of the earliest atomic models. Here are some of the models of the atomic structure. I'll begin with Dalton's model, known as the billiard ball model, defines an atom as a ball-like structure as the concept of atomic nucleus and electrons were unknown at that time. If asked to draw an atom, Dalton would have drawn a simple circle. This became Dalton's atomic theory, which states that all matter is composed of small particles called atoms that are identical in size, mass, and properties but differ in these characteristics among different types. Second, next we have the plum pudding model by J.J. Thomson, where it is being compared to a cookie or chocolate chip. This explains that the whole chip is positively charged or called the proton, while the chocolates are the electrons. Third, Rutherford's model indicates an atom is in reality empty space having electrons orbit the fixed positive nucleus in known predictable pathways. This is the model of an atom established by Ernest Rutherford, New Zealand native but working at Manchester University in England in the very early 1900s. Last but not the least is Bohr's model. According to the Bohr atomic model, a small positively charged nucleus is surrounded by revolving negatively charged electrons in fixed orbits. He concluded that an electron will have more energy if it is located away from the nucleus, whereas electrons will have less energy if it is located near the nucleus. Next is the valence electron. In chemistry and physics, valence electrons are those electrons in the outermost shell of an atom and those that can take part in forming a chemical bond if the outermost shell is not closed. In a single covalent bond, a shared pair forms with both atoms in the bond, each contributing one valence electron. How many valence electrons does an element have? You can use the periodic table to help you determine how many valence electrons as an element has. Look at the group that the element is in, as the group number indicates the number of valence electrons that the element has. Note, however, that this rule only applies to elements that are not transition metals. Transition metals have more complicated electron configurations. Thus, you should take a look at the element's specific electron shell configuration to figure it out. For the oxygen atom, the outermost shell contains 6 electrons, giving it a total of 8 valence electrons. In contrast, neon's outermost shell has 8 electrons, indicating it is fully filled. Each shell can hold a specific number of electrons determined by their sublevels such as S, P, D, and F. Example, magnesium has 12 electrons and fills its first 2 shells to their maximums with 2 in the first shell and 8 in the second, leaving 2 electrons in the third shell. Phosphorus with 15 electrons also has 3 shells, fully occupying the first two and placing 5 electrons in the third shell, resulting in 5 valence electrons. Now that I've learned this too, this lecture can help me with my assignment. Thank you so much, Teacher Rhianne. No problem. This is Rhianne Escat, zooming out.